Hello, I'm Dane, and this is Dan Explains. It's that time of the year again, where, at least in the northern hemisphere, the temperatures start to get cold. And in many places, cold, white, slippery, wet garbage falls from the sky, not only wrecking our backs, but our cars, too. Well, why do we have to deal with this? More specifically, what causes the seasons to change? It's probably more complicated than you think. Let me explain why. In elementary school, many of us naively believe that the seasons are caused by the distance of the sun to the earth. However, then you find out that when it's winter in the northern hemisphere, it's summer in the southern hemisphere. If the seasons were caused by the Earth's distance to the sun, then you'd expect the seasons to be the same in both hemispheres at the same time. Also, surprise, surprise, at least for us in the northern hemisphere, it turns out the Earth is closer to the sun during the winter rather than further away. Of course, the biggest reason for the seasonal changes is the 23.4-degree tilt in the Earth's axis. When one of the Earth's hemispheres is tilted towards the sun, then that hemisphere is in its summer. When it's tilted away, it's winter. This tilt causes a double effect. First, the length of the day changes depending on the season. Well, actually, not really the length of the day, which pretty much stays the same year-round, but the length of the daytime versus the length of the nighttime. The more hours of sunshine during the summer gives the sun more time to warm things up. Also, secondarily, the tilt towards the sun changes the angle the rays of the sun hit the Earth at, increasing its overall intensity. To explain what I mean, imagine if you were using a flashlight to see at night. If you shine the flashlight straight down at the ground, it creates a circular spot. Now if you angle the flashlight, it creates an elongated spot. The area of the elongated spot is larger than that of the circular one. I'm not going to go over the math that describes the change in area, but as you can probably imagine, if you spread the same amount of light over a larger area, you will get less heating per square foot. If it wasn't for this, you'd expect the poles to go from frigid ice boxes in the winter to burning hellscapes in the summer. Because if you're exactly at the poles, excluding atmospheric effects, the sun is only up during the summer and down the whole winter. However, the sun is at its highest point on the summer solstice, and that'll only maximize at the axial tilt of the Earth, which I already mentioned before is 23.4 degrees. Although those two things are the major causes for the seasons, there's a lot more to it than that, where every year would be the same and the seasons would be totally dependent on how far from the equator we are. The first thing I assumed as a kid was that the southern hemisphere would have on average more extreme seasons than the northern hemisphere, because its summer occurs when the Earth is closer to the sun, and its winter while the Earth is further away. Well, as you might have guessed, that's wrong. The southern hemisphere has a seasonal variation of about 7 degrees Celsius, compared to the northern hemisphere's 14 degrees Celsius. That means the northern hemisphere averages twice the amount of temperature swing between the summer and winter than the southern hemisphere does. If you look at this map, the reason for this may become obvious. Most of the land on Earth is in the northern hemisphere. Water acts as a temperature moderator and also has a huge effect on weather patterns across the globe. Because the South Pole is surrounded by the ocean, the southern jet stream wanders less than its counterpart in the northern hemisphere. This effectively locks the vast majority of the cold in the southern hemisphere closer to the South Pole. This helps to make Antarctica the coldest place on Earth, and for the most part protects countries in the southern hemisphere from visits by the polar vortex, which loves to pay us a visit in the northern US and Canada during winter. Also, air flowing around the globe in the southern hemisphere spends much more time over water, moderating the air's temperature. The more complex continental shapes in the northern hemisphere also means that the distance from the North Pole doesn't really mean that much. For instance, Boston and Rome are about the same distance from the North Pole, yet they experience vastly different weather. This is because warm water from the equator flows north along the east coast of the United States. This forces the northern jet stream, and the cold air with it, north as it crosses the Atlantic Ocean. The opposite happens in the Pacific Ocean because the ocean is much larger than the Atlantic. and the cold water is pushed down from Alaska towards the west coast of the United States. So, cold fronts tend to be pushed down from Alaska into the continental US. As you might imagine, it would be bad news for any warm weather-loving Europeans if the warm equatorial water flowing north from the Atlantic decided to take an extended holiday. Well, people are worried about just that happening. But that's a story for another video. Thank you for watching. If you like this video, please press the like button. Subscribe to my channel and ding the bell to get notified when I post new videos. Also, please support me on Patreon, link in the description. The more people support me, the more time I can dedicate to making videos like this one. So, until next time, have a great week.